Welcome to Summarize Science. Today we are looking at a breakthrough in how AI understands and simulates our actual world. Most video-generating AI models today are great at making up visually plausible but entirely fake environments. If you ask a standard AI to generate a video of a city, it usually just imagines the buildings and streets out of thin air. The researchers behind the Seoul World Model, or SWM, wanted to change that by grounding AI in the real city of Seoul. By using over 400,000 street view images, they anchored the AI's imagination to actual geographic locations. This allows the model to generate continuous, dynamic video of real surroundings along a path chosen on a map. Users can even add creative prompts, like seeing a massive wave in a city or a fictional monster appearing between skyscrapers. However, building a digital twin of a city from photos comes with massive challenges. For instance, street view photos are often taken at sparse intervals, meaning there are huge gaps in the visual data. To solve this, the researchers developed a view interpolation pipeline that fills in the blanks to create smooth motion. They also used synthetic data from a driving simulator called Carla to teach the AI how pedestrians and cars move. Another problem is that photos contain temporary things like parked cars or people that change over time. Through cross-temporal pairing, the model learns to focus on the permanent structures like buildings while ignoring the temporary clutter in the photos. You can see here how the AI selectively attends to the persistent layout of the street. Long-distance simulations are notoriously difficult because AI models usually accumulate errors and become blurry over time. The solution was a virtual look-ahead sync, which essentially gives the AI a destination image to aim for. This keeps the generation stable and clear for trajectories reaching hundreds of meters or even kilometers. The model was tested not just in Seoul, but also in Busan and Ann Arbor, Michigan. Even though it was never trained on those specific cities, it outperformed other world models in keeping the layout accurate. Looking at these comparisons, standard AI models often drift away from the map or produce warped structures. SWM remains faithful to the real-world geometry while still allowing for creative weather and lighting changes. This is a huge step forward for several fields beyond just making cool videos. It could be used by urban planners to preview how new streetscapes would actually look and feel. It is also invaluable for testing autonomous driving systems in high-stakes scenarios without any real-world risk. Let's recap the important points of this study. This work proves that we can anchor powerful generative AI to the real, physical world using existing map data. By solving issues like data sparsity and long-horizon drift, they created a stable world model that isn't just a dream. In the future, this might mean that every inch of the globe could be simulated with perfect accuracy. This would allow for location-based exploration and highly realistic digital training for robots. Thanks for watching Summarize Science, and stay tuned for more bites of the future.